So, welcome to Microsoft Ignite the Tour, Netherlands, here in Amsterdam. And today we're going to be talking about migrating web applications to Azure. Why? Well, here are the goals for this session, and I hope you learned something because I actually learned a lot putting it together for you. We're going to migrate a data center hosted application to Azure. We're going to review the available endpoints that we can move our application to. We're going to modernize a lot of operational tasks that we used to have to do all the time. And then I'm going to do a demo. I'm going to show you today how you can build a couple of containers and build an application. And it's not quite as scary as a lot of people think it is. So I'm going to ask you all a question. Where are your applications? And don't tell me, they're in the App Store. Or, you download them from a binary pack. That's not what I'm asking you. When I ask you where your applications are they hosted in a data center? Does anyone have a data center still hosting their app workloads? Give me a hand, please. Cool, so some of you are still dealing with this, but I bet you, after years and years of running a really successful solution, it looks less like this and maybe closer to this. I have been in these types of data centers. I've dealt with this, and yikes. This hits close to home to some of you, I'm sure, where you've been in situations where you have the best of intentions when you built out that data center. You said, hey, we have control over everything, and we can build our networks the way we want, but then you end up with this giant mess. That's not cool. So it's 2019. We have the cloud. So let's ask ourselves this question. What are still the drawbacks of being hosted in your data center? And the number one thing that I like to think about, aside from all the cash that you have to spend up front to actually acquire a data center or build it out, rent it from a co-location company, and let's not forget electricity, power, blah, 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 all those things that you need to take care of. And you're also making an assumption. What is that assumption? That I don't want to buy more or less hardware. You're just buying hardware, you're assuming scale when you're starting up. And that could be a little difficult. So you could also get yourself into situations like expensive compliance requirements. And let me use 4 letters you all know very well in this part of the world, GDPR. So think about building a data center and still building it compliant to GDPR in 2019. That's rough. Now let's talk about the benefits of hosting in Azure. So number one, and this is the thing I love to tell people, no more hardware to manage. And that's a real benefit to people who just want to build and build rapidly. And you're always up to date because the hardware, the firmware, the operating systems that are associated with most of these systems are taken care of for you. We have flexible costs, so we don't have to be so concerned about all that capital expenditure because what we can use is a pay-as-you-go kind of methodology to use our systems. And I know a lot of you like to add little cute names to your servers, like Harry01 and, Cool Server 27. No, that's fine if you want it, but the thing is that you don't need to create an emotional attachment to that machine. That server should serve one purpose, and when that purpose is complete, get rid of it. So if you want to keep your cute names, you can, but you could create them as just metadata tags. So let's move over to the cloud. Let's get out of the business of hurting hardware. Let's get into the practice of building systems that are going to grow with you. So hi, I haven't really talked much about myself yet, so I figure I'll get that done now. I want to just get towards the content and make sure that you learn tons. So first of all, my name is Jay Gordon. I am a cloud advocate. I work, of course, for Microsoft, and I live in New York City. It's really cool. And if you would like to get in touch with me afterwards, you can find me on Twitter and on all the other things like GitHub at @JDestro. Cool. So let's talk about this company. Anybody familiar with Northwind Traders? Anyone? They are one of the most popular fake companies in the history of Microsoft. We like to use them as an example of this company built this and this company built that, and it's something that some of you in the Microsoft ecosphere may be familiar with. Well, here's a big news. Tailwind Traders, the other cool fake company that we like to talk about, they have just acquired Northwind. So now we have one of the biggest fake companies in the world, and they build products, they sell products like aniseed oil and all sorts of weird things. And like a lot of companies, when you purchase someone else, you're not just buying all that cool stuff that you're going to start selling. You're buying technical debt. And what do we mean by technical debt? But you know that big mix of ugly data center and technology sometimes that happen after years of building and building and building and not maybe modernizing because you just want to keep things up and running. Well, that's kind of where your technical debt comes from, and that's what Tailwind Traders acquired. They acquired this inventory system, which is essentially technical debt. And this technical debt is made up of several different pieces that we're going to talk about. Now, there are two APIs, which are a .NET Core API, and that's back-ended by SQL Server. And then we have a Node.js API that's providing services, and that's back-ended by MongoDB. So we're keeping everything for information about our products in a NoSQL document database. And that made it a lot easier for these companies to start considering how to store data, how to describe what products are. So they decided, let's keep product descriptions in NoSQL, and then what we're going to do is keep the inventory system in our .NET Core app and keep all that pictures and the total number of items in the SQL Server database. Now, what does that mean? That means it's a big system that we kind of have to look at. Now, this is what they're acquiring as technical debt. Now, that technical debt is just for this one piece that they're migrating over. So we have 4 servers. We've got our Node.js, we've got our React, which is a front end for our Node.js and our .NET APIs. We've got our data layer, and our data layer is made up of a MongoDB replica set and SQL with 1 failover. And then we've got our backups and monitoring. So who here knows Nagios? Cool, you know, when it's open source, and when they got started, they figured, let's just use what we know. Let's use what we can. But modern times may not show that Nagios is the best solution for them in this particular case. Maybe they want to have management associated with their monitoring. And then there's Bakula they had. Anyone here use Bakula? Okay, cool. Bakula is another open source product that they used because they knew it to build and manage their backups. And of course, how are you connecting everything together? With networking equipment. So that's another team that has to manage. So that's a whole data center, all this gear, and all this important equipment we need to consider. So here's our migration path that we're going to take today. We're going to move to an elastic solution. And when I say an elastic solution, I say a solution that is going to both grow and shrink with your company. So if your company has what I like to call a thundering herd, group of people that run toward the website, you can scale up easily. And if you are reaching a point of minimal traffic, you can scale down. That's what you want to consider. You want a fixed cost to be more growing with you and decreasing with you as your business needs to shape and change. And that's why we go with an elastic solution. We're going to also reduce some responsibility. So we used to have people that would have to manage networks, and that meant physical connections, making changes to firewalls. We had people that would have to run and make changes to our routers, things of that nature. Well, we're saying no more to that. And we're going to modernize for more rapid deployment. And what does that mean? We're going to use more modern tools rather than say FTP up something or, ask the person to run the script that does the deploy, as we all have been in situations like that. At least I have. So when you talk about moving to something like Azure, you look at all these services. I mean, look at everything we got here from media, CDN, integration, compute. I mean, there's so many options, and you may be looking at this a little overwhelmed saying, well, how do I get that multi-part application into this? Well, what I'm gonna do is just give you a couple explanations on all the different options. So virtual machines are a part of infrastructure as a service. Or think of the idea of lift and shift, as some people want to say, of just taking a product that might be a certain code base or some binaries, picking it up and just moving it along. So Think of it in a way of saying, I just want a VM. I want a full operating system. I don't need to manage the gear. I don't need to concern myself with connecting and connecting other physical networks. So we'll have easier to manage networks. And a lot of the things that you need as far as the operating system, if you want to manage, you're capable of doing it. So if you want to run Ubuntu, you want to run Windows, you want to run FreeBSD, these are all capable to be done on Azure through using our VMs. And we have things like security built in, so out of the box, you can create policies to limit who can access what you have. So let's go and talk about platform as a service. So when we get to platform as a service, we take a little responsibility away from you. And we tell you, you know what? It makes a lot more sense for you to just worry about the code. So rather than spend time building systems, you can just work on code and then build pipelines to deploy that code directly to application services that will provide you with everything from HTTPS for your app or your API. It'll provide you with management for cores, DNS. You can add as many different host names you need. So what you're getting are great defaults out of the box and the ability to customize a way to deploy quickly through continuous integration and continuous deployment methods. So you can use a lot of the tools you already know, or you can integrate it with tools that we already provide like Azure DevOps. So let's move a little bit further and talk about those databases. So much like platforms as a service, we have databases as a service. So I've worked at database companies in the past, and let me tell you, managing databases can be kind of a lot of work. You know, you have to concern yourself with all the other things you have to concern yourself when it comes to regular systems, but databases tend to be constantly moving, updating, changes being made, and you have to concern yourself with always having backups, and that can take a lot of work. So what we do as a database as a service is say, provide us with the actual database data you have, let Microsoft Azure, through the different types of services we have, such as managed Cosmos DB or SQL Server for Azure, what we do is provide you with simpler ways of managing your databases by saying, provide us with the data, tell us where you want to connect your database to, and that's all. And then there's the network. So we used to have a network team, and that team would have to go ahead and manage our networks day to day. They would get requests and say, I need this IP available, or I need this firewall port open, or as network people will do. You had another layer of management, another bit of operations overhead that you had to consider. Well, thankfully, you can virtualize these networks. So you can put them into code and manage them that way. So your networking team can now retrain. They can be part of developing services in code as opposed to having to go to the data center, replace the broken switch, and then go back to the office and tell you, I now have to RMA this broken switch. We don't need to do that anymore. So this is kind of a network diagram of the application we are going to move today. But I want to tell you that what we're going to do is go down the line and show you the parts that are eventually going to move. So let's get started with our connectivity. Now we see we've replaced all that network gear that we needed with the Azure Virtual Network, or VNet. Then eventually what we're going to do is replace the MongoDB replica set with Cosmos DB. Cosmos DB is going to provide an API that speaks and works with the MongoDB API so that you can go ahead, create apps, but have management behind it. You don't have to manage those 3 replicas. And let's move a little further along and remember that SQL server I told you we needed to manage. Not anymore. Now we can use our hosted service on Azure. We go a little further along the line. All those application and web servers we have replaced with APIs that are based on app service, and we're going to create containers. We're actually going to be able to do it with a little bit of customization if we want to by using Docker files. And all of our backups and monitoring, they're just replaced with services that you get out of the box and default with Microsoft Azure services. So it's time to demo, and that's what all you all came here to see today, right? You want to see how this works, correct? Cool. So here are the services that we're going to migrate to. We're going to use app service, which is going to provide us containers. We're not going to have to worry about using Kubernetes. We're going to get started very simply by showing you how to just use Docker to build and then deploy your application with very, very quickly. After that, we are going to show you how to replace MongoDB with Cosmos. We're going to go ahead and move that unmanaged database to a managed database service with SQL. Azure DNS will take care of all of our name services, so we know when we're done, we can point our host names and move on with our life. And then, of course, all that networking that we need to do, the security, the VPN connections that we may need to do for offsite people, all the things we can now just manage within Azure Virtual Network. So, let's slide on in, all right? We're going to slide on in, and we are going to get started with our tutorial. And I'm going to go ahead and bring you to the demo portion of this. So let's get working. Cool. So here we are at the dashboard. And the dashboard is going to be the place we get started. And the first thing we're going to do is create a resource group. A resource group is going to kind of act as maybe like a logical container of where we put all of our items. So anything we create, we can put in this resource group, and when we're done, rather than have to do everything manually to tear it down, we can just destroy the resource group. So let's go ahead and create add. We're going to use Ignite the tour, because that's what we're on here. Then we're going to create a resource group, and just to make it so I can see it really quickly, we're just going to call it 0001, and we're going to call it TWT, Tailwind Traders. So now we have this region. Now, this isn't where this is going to live. This is actually where the resource group's metadata is going to live. So if the resource group's metadata is to fail, we know where it's going to live, and we know how we have to do a restoration from it. It's just a way that Microsoft ensures that there is data associated with your resource group stored at least one of the data centers. So we have all these different regions, and where are we today? We're in West Europe, so let's pick West Europe. We'll click Review and Create. And in just a second or so, we've created a resource group. And now within this resource group, we need to create those databases. So I'll show you very quickly how we can start creating an Azure Cosmos database. And it's as simple as clicking Azure Cosmos DB on the side. We'll click Add. We're going to use our resource group that we've already created. We're going to use Ignite the Tour as our subscription. We're going to just give it a name. We'll call it TWT API and MDB, MongoDB. So now we have these different APIs. So this is one of the benefits of Cosmos DB. If you want to speak to any of these databases using APIs that you know, you can. They are available. You can start working with Cassandra. You can actually do SQL queries against NoSQL data. And that's pretty cool. If you want to use time series, we've also got Gremlin for graph. So you've got tons and tons of information that you can store, but we're just going to want to store some documents. So we're going to use Azure Cosmos DB API. Then we want to use West Europe as our region. So now we're actually saying where we're going to host this data. But the cool thing is we've got geo-redundancy, which means we can select other places to keep our data to make it closer to our customers. So if we have customers in other regions, we can go ahead and say, let's place another set of data over there. So then we can say, read that region first. Cool? All right. So we also have multi-region rights. So we can actually tell you, not only can you read from that multiple regions, but you can also write data directly. So if you have members of your business that want to do business specifically in Japan, you can set up an endpoint in Japan. Sounds good to me? Sounds good to you? Let's review and create. And after a few minutes, we're going to go ahead and have a database. So we don't have to sit here and wait a few minutes. What we're going to do is move on to the next database we need. We need SQL. And just like we did before, we're going to click SQL Databases. We're going to click Add. And same situation. What I will do is pick our resource group. We're going to give it a name, and we'll just call it TWT SQL. Cool. And then we're going to have to select a server. So we actually have to pick the kind of hardware we want it to live on. And to do that, we can just create new. We'll give it a name, TWT SQL. Then we're going to give it, somebody's already using that. Let's got to be unique. So we'll call it TWSQL NL. Here we are. All right, cool. We have to have a username. Now, I am going to show you all a little secret. I keep this username and password in VS Code for this particular tutorial. So here we are. Just going to go and grab that password. It was right here. And of course, when you do something live, things go wrong. So let me just grab that password for you. All right, so rather than show you the password, I'm just gonna type a new one. So you can select the username and we'll go ahead and add a username. We'll call it TWT prod, whatever. We just create a random username. And then what we need is a complex password. I'm just gonna make up a complex password right here. We'll copy it, we'll paste it in again. Great, and then we'll pick our location as West Europe. Select. So now we've created the type of server that we want, and now we can actually pick the hardware type. So we have all these different styles of hardware that we can use. There are different classes. We have basic, and as you can see, that basic is great for demoing, for dev work, and it's only $5 a month. How can you go wrong? We'll click apply. Then all we have to do, go to our additional settings. We're going to go into our additional settings and we're going to have the ability to create it with either an existing backup snapshot or a sample, but we want none because we're going to move and migrate that data eventually. And then we're going to use all the rest of the defaults. We'll click review and create. We'll get all the information and just click create. And after a few minutes, it will start creating our databases. And what we'll be able to do very, very simply, when we want to look for specific information associated with connection strings, I've got some that are already ready and I can show you right away, is we go to our database server. And if we want our SQL information, we can see everything associated with the actual server itself. And then when we want to access it, we can go right here and we can see our connection strings. And then we can copy this and make it ready for our application. So we'll take this, we'll open up our VS Code, and we'll just store it for when we actually have to do our deployment. So next thing, same situation, we'll go back to our resource group.
Question about connection string. Can you drop the connection string?
I'll answer plenty of questions after. Thank you very much. So what we can do is now do the same exact thing for our Cosmos DB. We can go here and look at connection string. And as you can see, we've got all the information, the host, a username and password, and here's the really cool thing. If you are afraid of keeping the same passwords and you want to rotate them, simple as this. We've regenerated our password. We can create additional information. We have connection strings that are all here. Make it very, very simple for you to just take your primary connection string, copy it, pop it here into it for when we go forward and set up our configurations for our actual application to piece together. Cool, so we've created our databases. Now, here's the thing. We typically want to talk to you about these database migrations, and they are a wonderful, wonderful discussion, but I am not going to be doing that portion of the migration today. What my portion is going to be giving you how to take Docker and use Docker, and Docker is a great tool to containerize environments. We are going to use that and move our application into Azure's container services. But we still have to migrate those databases. And I like to kind of liken database migrations, because like I said, I worked at a database company for a while, and I talked to people a lot about database migrations. And I look at database migrations as taking a giant room of puppies and telling them they have to go into another room. Like literally saying to them, hey dogs, go to that room. You can't control what puppies do. They're constantly moving around, they're making noises, and they're leaving bits of archives all over the place. So I don't have the time today to tell you how to move a bunch of puppies, but if you go to migration session 2, you will be able to meet Laurent, my coworker, and he is going to give you all the information about how to take those 2 databases that we had and move them over to those 2 endpoints we created. So stick around for the MiG-20 session if you can, okay? Cool. So now we've set up the data storage, but we still need to create the places for our application, right? So let's talk about our application a little bit. I gave you some minor description of it before, but let me get a little bit deeper. So Tailwind Traders product service, like I said, is a MongoDB-backed application. It runs with Node.js, and it's a simple API. You have all the information here that you can see and the variables that we need to have so that we're actually able to run it. Now, we have our inventory service, and that's our .NET Core portion. That's what's going to store our images, and that's just another REST API that we've created and that we need to manage and then eventually deploy. And these are all stateless, that they're going to be, the actual applications themselves are stateless. They keep all of their actual data in a database remotely. So the hosting environment doesn't need to be able to keep state. So containers make a ton of sense. And that same thing can be said about the front end. The front end is just React. And as you can see, all it does is need 2 environment variables to say where the APIs are so it eventually can move everything over. So typically you would have to manage some sort of connection string file where you would have environment variables that would eventually be passed. And so that would be something that you would have to go in and make changes during development and then to make sure that you've made those available to your application when you go to production. So let's go to the portal and let's show you a little bit about how we're going to get this started. So we're going to go back to here. Let's go to mirror. Cool. And what we're going to do is create what's called an Azure Container Registry. And that's going to be where we create and store Docker container images that we're eventually going to deploy to Azure App Services. So what I'm going to do is go to my resource group. I am going to click add, and I can search within everything and just type Azure. Sorry, I always feel nervous typing in front of people, and this is a lot of people. So container registry, cool. So we're going to go to container registry, and we'll click create. Great. So now what we're going to do is just create a place to store our Docker images. So I like to make sure it's all at the top, so I'm just going to call it a 01. You don't have to call it this, obviously. And we'll call it TWT. Cool. We're going to use our same subscription, so all the billing goes to the same place. We'll use the same resource group so we can trash everything. We'll pick West Europe because all of our other resources are there. We're going to enable an admin user because we want authentication when we actually store things or grab them. So we'll click create, and in just a few seconds, our ACR, Azure Container Registry, will be created. So there you see, deployment in progress. We'll go ahead and click that. Hey, complete. Let's go to the resource. So now within here, we're able to see all the different access control that we can create. So if we have RBAC users in Azure Active Directory domain, we can use those. But we also have access keys. And these access keys can be used to do simple Docker logins. So that's what we're going to do. We're going to log in via Docker to this server. So I'm going to click login server. And then what I'm going to do is go over to one of my terminals. And what I'm going to log into is Docker login, and I'm going to state the name of the ACR. Hit return, username. Ooh. And the username is as simple as just going back here. Copy. I've got to get that better. There we go. And then go right here. There we are. So now we're logged in. And now that we're logged in, we can actually start taking the different portions of our application and Dockerizing it. And the first step in that is taking each section of those APIs and creating Docker images. So first what we need to do is grab the login server because we're going to need that to state where we're going to create and store this image. So I'm going to do Docker, which is going to invoke the actual Docker binary. And then I'm going to do build which is going to say, I want to build a container, minus T, which just means tagging it. So we're going to tag it within our ACR. We need to give a location. And then we're just going to do a slash like we would for a URL. And we're going to name this one product service. You can see we're in the product service directory, and that's part of our full repository. We've got front end, inventory, product service. We're not working with reports today. So now we're going to say docker build minus T, and we're going to give it a name, product service. Very simple. And then we're going to tag it. And we're going to tag it as latest. Now, when you build something, you want to build it in the directory you're in. So what we're going to do is just say dot. That's it. So what it did was followed some instructions. So let's take a quick look at those instructions. A Docker file is simply a set of instructions on how an application should be deployed to Docker. And you can see right here, it's very, very simple. We're just creating a directory. We're copying the contents of the source into it. We're doing an npm install, and then we're starting it. And then once we actually take that container and load it into Azure Container Services through App Service, we're able to just expose that 8000 port over to port 80 and 443. So we've got it fully SSL enabled and a host name with a fully qualified domain name. Cool? So after we've built, now we can push this. And it's really simple to do. Get rid of the period. Excuse me. Let's get rid of that period. And then we don't need the minus T anymore because the tag has already been established, and we don't need to build. We're just going to push. And there you go. Now it's just pushing it up to the repository. Now we have to do that for our other API, which is the same thing. So let's look at the Docker file while that's building. And as you can see, it's got a .NET image that it's basing this build off of, and then doing the .NET publish so that we can have our application. So same situation. Docker Docker build minus T. And then we'll say our tag is inventory service. And remember, of course, we're going to need our ACR. So inventory service slash like that. And then, of course, the tag, and I'm just going to call it latest because it is the latest version. And period, because we want to do it in the directory we're currently in. Same situation. And now let's push it just as fast. Don't need that period anymore. Take care of the minus T and the build. Just make it push. Anybody seen me need to use Kubernetes yet? Exactly. We don't need Kubernetes. It's useful, but we don't need it to start building our applications with Docker. And that's the really cool thing. We can create everything, get your containers built, and start deploying apps. So we've got one more to go, and that's our simple React front end. As we can see, front end. So we're just going to do the same thing. Docker build minus T. Our ACR, front end service, and then latest. What did I do wrong? Oh, forgot my period. See, if you don't have your period, you're not saying where it's going to actually build. Quick, easy. Let's get rid of that period. Same situation. And then what we're going to do is go back to the, we're going to go back to the portal. And within the portal now, you're going to see these repositories are now represented within because they've been created. So we can go to front-end service and we can look, there's our latest version of it. We have all the information with the tag creation date, all the run IDs, platform that it can run on, which is Linux, and the digest, so that if you are concerned and you want to be able to make sure the image matches the SHA digest, you can. All right, so we've got our images created. They are uploaded over to Azure. And now we want to actually deploy them. And now we're going to do that with a very simple service called App Services for Containers. And so what I'm going to do is take it back to my dashboard, and I'm going to show you I've created a shortcut here, Web App for Containers. Web App for Containers, just you can create simple containers, like I said, without using complex services like OpenShift or Kubernetes to manage your containers. You can just create it within Docker, upload it, explain how much scale you need, and then go. So we're gonna need 3 of these. So let's create the first one. The first one, I'm just gonna call it 0001 TWT product service. Cool. We're going to use our existing, we're going to use Linux, and then we need to create the kind of hardware we want to run our containers on. So an app service plan is just giving you all that information about what the hardware that you're going to use is going to look like. So we'll give it a name and we'll call it TWT 0001 TWT is the service plan. So this is how you can get granular information when it comes to billing. Everything is nicely separated. So you can find out how much did app service cost us this much? How much did databases cost us this much? Okay, so now we're gonna pick our location. I kind of wish I was in the central US, but this is a really cool place. So we're gonna just stick here and stick with West Europe. And now we've got our pricing tiers, and our pricing tiers give you the ability to take a look, and you can do dev test. It's very, very inexpensive, 35 American dollars. And of course, production, it's a bit more expensive, but you get tons and tons of features. Like I said, SSL, you can auto scale things, staging, so you can have multiple versions and then have, say, a blue-green deployment. If you want to allow, say, 10% to go to the new version, leave 90% to the old version, you can do that with slots and then easily say, all right, time to go to slot 2 and go 100%. It's a great way to make your deployments have a little bit of a canary style of testing. Traffic Manager helps you move where your traffic goes globally, and then you have tons of memory to run your app and storage if you need to store anything statically. So what we do is just click apply, and now we've got what our hardware is going to look like. And now it's time for this particular API to get its container. So this is the product service. And so what we're going to do is find our registry that we've already created, because we have a couple of different options. Now you can use quick starts, and there are a couple of demo containers if you want to get started trying with them. So Nginx or a Python Hello World. Docker provides you with a place to store, but that's a public registry. You can create your own private ones if you'd like to. It's a little bit more work, but we provide you obviously with a hosted option. And so what we'll do is pick 0001 TWT. Now we can pick the actual image that we created for the app service, product service, the latest tag. We don't need a startup file, but if we needed something to run during cloud init, if you would, we can have it. So maybe we needed a particular agent to run. We have a script that needs to happen. We can make it part of the startup file. And then we click apply and then create. In a few seconds, we're going to have a new container created. So let's go ahead and create the next one. Same situation. We want one for our inventory service. Inventory service. So we'll go to 0001. We'll keep the actual application plan that we've already created, because we don't need another one. And we're going to be using Linux for all these. Even in our .NET application, we don't need to run it on Windows. So we'll click the container, Azure Container Registry, same one. Now we pick inventory service instead, same thing with our tag, apply, create. This is how quickly your deploys can go manually. Now imagine once you create a pipeline using something like Azure DevOps. Now, one more to create for our front end. Create. Go away, Siri. Same situation, use the existing group. Linux, ACR, registry, our image, not product service. We're going to pick our front end service, latest tag, apply. All these are going to create and then be available within your resource group. Now, anybody here like to watch cooking shows on TV? Come on, somebody here has to watch. I like Chopped. So one of the things that on a lot of those cooking shows is they they get things started in the oven so that they don't have to do it live. Well, I've done that for you right now. I've got some stuff that I've already cooked. And I want to show you how these things start to fit together. So let's go to my complete dish. My complete dish will look a little bit more like this. Now we've got all the different portions of our application that we need that have been created in Azure. We have our ACR, where we're going to store all of our Azure containers. We have our services for our APIs, inventory, front end, and our product. We've also got our SQL databases and our Mongo databases now stored in Cosmos DB. Our virtual net is taking care of all of our security. And let's see how this all fits together. So you saw we had to take care of some environment variables. Well, I've already done that for you, but I want to show you how it's done. If we go into the product service, we need to be able to provide a database. That database can be provided very easily here in application settings. If we go into application settings, we scroll down, we see these application settings right here. These are environment variables. They will be available within the Azure Linux container that you create. So if you need to state that the database connection string has to be this, and yes, it can be encrypted. Sorry, I couldn't mention it then, but we have Azure Vault services that you can encrypt stuff and then eventually leave that in here. For right now, I'm just showing you the demo of the basics. But here's our MongoDB data connection string that's going to go to Cosmos. And all we have to do is paste that in and click Save. Same situation now with our inventory API. In this case, when we go down to application settings, because it's using the native SQL server, we actually have a section within here for connection strings that shows you that the name of the connection is inventory context. Here is the full connection string that's here on Azure, and we're stating that it's a SQL Azure. So it's going to go ahead and make that network connection and use all the existing RBAC and information that you may have if you have specific security policies already created. And then finally, we're going to tie it all together with that front end and the two APIs that we just created, because if you see, each of these has a full URL. So if you just give me 1 sec to show you, our inventory API, that's our URL right here. And what does that look like? Well, I haven't added security against that API yet, but when we go to our APIs, they start looking like this. So here is our inventory service API. You can see the full host name. Here is the actual API for the product service, all the documents that are stored in MongoDB. What we've done here is we go to application settings, and we've got some, pardon me, I need to go to the front end one. We go to our front end, we go to application settings, and then within application settings, you'll see we've got inventory service base URL with the base URL for our API, and product service base URL with the product service URL for the API as well. So now we're connecting all this together. We don't have to manage manually those connection strings or any of that within config files and then store them in some sort of repo. We can just do it right here. And here's the really awesome part about all of this, is that we have ways for you to go ahead and take all of this and codify it through ARM templates. So what we can do is go back here and take a look at all the different methodologies of deploying this, because we have our ARM layer, and it's a unified layer. So the things that I showed you today eventually created this particular app. And that ARM layer I was just talking about, all the things that we just built to create this website, we didn't need to do it all manually. The Azure Resource Manager layer that comes along with using Azure allows you to do all the things that I did today, either via using the Azure CLI, which is just a CLI that you can use in either PowerShell or Bash. You could do this via the SDK using APIs that we provide you, or you can just do like I did, right in the portal. So there's tons of easy ways for you to build these things. And I wanted to make sure that you saw the simplest and quickest way to build an application. And as you can see, we can add, remove portions of our application, and that's that. So let's start wrapping things up. What do you say? So this is what we're left with now. Rather than having that huge network diagram with all those different parts that we needed to concern ourselves with, say building backup services, building database services, creating monitoring. Now that's all going to come with the services that we've put together with fully managed Azure services that we now have in production. So let's wrap it all up. What did we do today? We migrated the Northwind and Tailwind Traders application from the old data center over to Azure, which used service-based endpoints. So they're no longer manually doing backups. They're no longer manually responding to everything that happens when a failure occurs. We've modernized a lot of the operational tasks. So your team's no longer having to go to the data center, replace tapes. Your team's not going to the data center and reinstalling switches because of broken line cards. Now your team is improving your application. They're improving how time to deliver is made by your actual development team. Your ops team is now empowered to help you grow as opposed to just keep maintaining existing hardware. And more than anything, I've given you a simple application that if you'd like to, you can build on your own using all the same resources that I've shown you here today. So there are a few more sessions in this particular learning path around migrations that I really recommend you go to. 20 is going to be a perfect tie-in to what we've learned today. And we're going to go ahead and give you the next step in the database portion of the migration, because database migrations suck. No other way to put it. They are really hard. But my coworker Laurent is going to show you how to make them a little bit easier. And then we've got tons of more showing you how to modernize your applications with containers and serverless. Anybody here work at a place where you have a cron server? That server that runs one cron one day? Let's not build cron servers anymore. Let's build serverless jobs. So go check out that. And then of course, we've talked about how to get started with containers, but if you want to build really huge applications, you can do that with Azure Kubernetes service. So get your lesson plans together, get your code for all these sessions, and enjoy yourself here at Microsoft Ignite. So thank you very much. I'm Jay. I'd love to hear from you. If you enjoyed this session, what I'd like you to do, go on Twitter if you have a Twitter account and just say, thanks, Jay Destro, loved your session, and I'll retweet you because I want the world to know that you were here. So thank you very much. Enjoy yourself here at Microsoft Ignite the Tour. I got about 10 minutes. I'm gonna hang out here. If you have questions, I'd like you to come up here because I want to talk to you one-on-one. I hate doing this screaming question answers back. So come on up to the front. I'll talk to you. Like I said, we got about 10 minutes. So thanks a lot for being a part of this. I'm going to do something that a lot of people don't do. This is a big room. Thank you for being here. No, wait, I'm clapping for you first. Thank you all for coming here today. You were great. Thanks. Give me now. Now you can give it to me.